Good afternoon, guys. Today we will be going through star and delta connections in resistance, and actually what are the voltage relation with respect to phase and line current, and current relations with respect to I line and I phase, means line currents and phase currents. Now in delta connection, what actually is the VL equal to V phase and IL equal to root 3 I phase. In same way, in star, current is same, phase current and line current, and VL equal to root 3 V phase. Now, in this case, if you look properly, in delta connection, the neutral is missing. Here, the neutral is connected to ground for balancing the system. Delta connection, you can say, delta connection is in this case, and this is star connection, you can say. This is the neutral. RYB. As this is earth, neutral is grounded, and here the neutral is not present because all the currents will be circulated in this way. All the currents will be circulated current concept in delta to reduce oscillations in the system. In order to reduce the oscillations or any kind of disturbances in the system, we are going for delta connection. And in case if you require a single phase supply, or you require unbalanced load in order to supply the unbalanced load, in that case these connections will be helpful, the star connection. And here the neutral is always earth, because if you keep the neutral oscillating or on earth, the unbalanced currents will be deployed into the system, and it will disturb our network, it will disturb our frequency, it will try to create a frequency of M into F. You can say this is harmonic frequency, harmonic frequency or harmonic currents, you can say harmonic RMS currents. Harmonic currents will be present if you keep this unearthed. That's why we are always connecting neutral to earth of any equipment or any transformer winding connections. Now in this case, actually this kind of arrangement is, you can say, as parallel arrangement, and this is same as that of series arrangement. The analogy is same that of series, because in series the currents are same, voltage is divided. Here the voltage is same and current is divided in between the phases. Now what is line voltage and what is phase voltage? Here the line voltage equal to phase voltage means, as neutral is absent here, VRY is equal to VRN if the external neutral is also taken into consideration. External neutral is taken into consideration, and in this case the VRY is equal to root 3 into VRN. You can see this is nothing but phase voltage. You can say it as the voltage across this will be VRN. This is nothing but neutral to line, that's why this is phase voltage. Now actually, as per our line diagram, or you can even draw the phasor diagrams. These phasor diagrams will be explained later on, because we have just gone through a DC circuits. I am just going through an overview, because it is very important to learn these concepts, and accordingly now what I will be doing is I will be deriving the star and delta connection resistance equivalents. That's why I have just gave you the information in nutshell. Please take it down. Now these concepts just now we have studied, it will be helpful to you in this concept also, because now what we will be doing is we are drawing the resistances in delta. Suppose the same value resistances are taken into consideration, and here also the same value of resistors are taken into consideration. Now accordingly what we will do is, in order to convert delta to star and star to delta, what you will do is, just you have to multiply the adjacent resistors. Actually let it be A, B and C. The value of resistors will be A, B and C in star. Now in order to calculate RA, what you will do is, you will just multiply these adjacent resistors which are connected to the element A, means element RA resistor. Now R into R divided by addition of all the three resistances, it will be R plus R plus R. Now this RA will be R square, you can say R square divided by 3R. In this case you will get cancelled R by 3. This R is nothing but the R delta. R is equal to R delta. Now you can prove that this resistance Ra is nothing but R star. R star is equal to R delta by 3 when same value of resistances or same same value of elements are connected in delta, and when we convert to star you can directly come across this formula, and by using this formula you can calculate the problem. Now in same way we can calculate this. This is one resistor, this is one resistor, and this is also resistor. Now if in same way this is A, this is B and C. Now in order to calculate the resistance Ra, what we will do is we will just sum up the two resistances plus R plus R and plus R into R divided by the opposite resistance R. Or in rather case you can also do one thing, that you just try to multiply each and every resistor with R into R plus R into R plus R into R divided by the rest R. But now in this case you can calculate as 2R plus R square divided by R. It is nothing but 2R plus R. It is nothing but 3R. Now as previously this resistor R is nothing but R star, you can write here R star, and this Ra is nothing but R delta in this case. Hence R delta is equal to 3 into R star. The same thing has been derived in both the cases. Please note it down because these formulas will be very helpful to you. I have derived in delta case also, I have derived in star case. Same example has been carried forward, and accordingly I have shown you how the R star is equal to R delta by 3, and the same thing is here, R delta is equal to 3 times R star resistance. This will be very helpful to you from the way of competitive exams, because many times in word problems they will be giving you a resistor in star and told you to calculate in delta. In many cases, now I will give you example of cable. In cable point of view, what happens is that the capacitance are connected in delta, and accordingly with respect to conductor and sheet the capacitances will be present. These are CE as these are connected to, and these are CC, you can say. This is for 3-phase cable. This is the case. In that case, what happens is that when you calculate the same thing, means delta connected capacitances and delta connected resistances, the calculation is different, because capacitance formula, capacitance in delta is equal to resistance in star. Capacitance in delta is equal to resistance in star. Same equations will be analogy. In same way, capacitance in star is equal to resistance in delta. Analogy. It will be very helpful to you while calculating these in your competitive exams. So please note it down. It will be very helpful to you.